Hi everyone, today's March 24th, Monday. Tonight's homework is 14-5, and tonight you will be challenged. Tonight you will not only be asked to remember what we did 2 weeks ago, but you'll be asked to now do something new. And the task that you'll be asked to do tonight is to graph a linear equation. And although that sounds very complex and difficult, you actually know how to do it already. You did it 2 weeks ago. You just didn't know it because we didn't label it graphing linear equations. So here are three things you're very familiar with, and we're going to just do a quick review. Here is an equation, here is a t-table, and you have x and y values, okay? I've gone ahead and done the first or 4 of the 5. Okay, this last one I'm going to save for you to see how it works on our graph. So if we were to plot the points, and I'll just quickly do this because I know we've done this before in class and all of you seem to have a pretty good grasp of it. When x, and again, these are ordered pairs. So again, if I were just to draw some parentheses around here, that really exemplifies what an ordered pair is when it's listed that way. Obviously, you'd have a little comma in the middle, and there's your ordered pair. So when x is -2, 1, 2 on the x-axis, right, to the left, y is 0. So that means our point is there. When x is 0, right at the origin, and y is 2, 1, 2 in the positive direction. Okay, and then we go ahead and plot that point. When x is 2, 1, 2, y is 4, 1, 2, 3, 4. There's our next point. Okay? Then our last one, when you plug in 4 into this equation, right? X plus 2, so 4 plus 2, you get 6. So the next ordered pair that we have is x equals 4, and then up 6. 1, 2, 3, 4, 5, 6. Now, as we did last week, specifically with the rocket diagram that you drew by connecting the plotted points, you may be able to see a pattern here, okay? Instead of just the points being randomly placed all over our coordinate plane, they are very linear, meaning they look like they could be in a straight line. And that is what graphing a linear equation is. Graphing a linear equation is basically taking the plotted points that you have discovered through plugging in numbers for x and seeing what y equals. You have created a linear equation, and here I can show you that by applying a straight line, and you'll want to use a straight edge, you can see that all of the points fall on this line. And what's interesting is that even though you may not have the value for x in your t-table, this can tell you that for infinite amounts of x or y values, you can see the relationship that this equation represents. Okay, so if I was to choose, okay, in this, if this was 3, if x equals 3 and I plug this in, y equals 3 plus 2, 3 plus 2 is 5. If I were to go x equals 3, 1, 2, 3, and then y would equal 5, 1, 2, 3, 4, 5, you can see that that plane is on our linear, or that point is on our linear equation. And that's what we're doing today, is basically connecting the dots. So what I'm going to do now is let's take a look at our homework, okay? Let's go ahead and take a look at the guided practice first. And in the guided practice, it asks us to make a t-table, okay? Right here. Copy the t-table, fill in the values using this equation. So again, plugging these values for x into the equation and coming out with y values. Then you're going to draw a coordinate plane like you see here, graph the equation, or you're going to plot the points. You'll plot these ordered pairs similarly like I did, and then graph the equation. Graphing the equation is just connecting those dots with a line. Okay. Now here in the guided practice, it asks questions that relate to the information that you can find above. So here in number 2, it says in the another example, and here's the another example, what is true about the x value and the y value of any of the points on the line. So basically it's asking you if a point is on this line, what does it tell you about it? So after you've had a chance to think about that, hopefully you'll come to a conclusion that brings you back to this equation. Okay, so I won't give you the answer, but what it's asking for is if you were to pick, let's say x is equal to -1, you can see that y is equal to -4. What if I was to pick x is equal to 0.5, -0.5, right? What would y equal? You can take a look at the graph and see that, okay, I could probably see that y equals -1.5. Okay, so it's asking you what is true about these two values. What do you know? What do they tell you about their relationship in this equation? Okay, and we'll discuss it a little bit tomorrow, and it might be a little bit hard to put into words, but I think tomorrow when we talk about it, you'll have a better idea of what exactly they're looking for. And then in the example up here where the Booster Club are making school pom-poms and they're talking about the supply cost, it asks why points with negative x values do not relate to the problem. Why would, say if we were on this, say we're using this number line, and why would it not make sense to pick x equals -1 if x is the number of pom-poms sold? Okay? Why does it not make sense to have a negative number as the x value? Think about that, and we'll share our ideas tomorrow in class. Okay? Our next set of problems is very similar to number 1, where you are creating a t-table, okay? And in that t-table, you are plugging in these x values, -2, 4, and 6. You're going to solve the equation and find the y values. Then you're going to draw a coordinate plane. You're going to plot the points, and then you're going to draw a linear equation through the points. You're going to connect the dots. That's what it's asking. So 3 things: create a t-table, plot the ordered pairs, and then draw a linear equation through it. All right, if you have any questions, please feel free to message me on YouTube. Now we get into some problem solving questions, and this is where you're going to have to pull out information in order to solve the problem. Okay, so here it says, during a movie matinee, the film broke, so the manager refunded the ticket price to everyone attending. Okay, if you use this table here and you read this carefully, you can answer number 12. Okay, number 13 says, suppose you don't know how many people were in the theater. Draw a graph of y equals 3x to show how much the manager had to refund the customers. Now I'm going to give you a big clue here. Okay, it asks you to label the axes by 5s. So what that means is that for every point on the x and y axis, it's going to have a value of 5. So here on the y-axis, instead of counting by 1s, which this axis does, see, it says 1, 2, 3, 4, 5, 6, you're going to count by 5s. So this would be 5, 10, 15, 20, 25, 30, and the same for the x-axis. Now the big clue I want to give you is that the y-axis is going to represent the refunds, okay? The x-axis is going to represent the number of people, okay? Excuse me. And again, it says you don't know how many people were in the theater, okay? So that allows you to pick values for x in order to find y. So what you're going to want to do is just pick reasonable numbers for x, create a t-table, and find out the value of what y is. Y is the refunds, x is the number of customers. Okay? Then you're going to plot those ordered pairs that you find in your t-table, connect them with a line, connect those dots, and you'll have your linear equation. All right, again, Message me if you have questions. I'd be happy to help you. Okay? Number 14 is asking you to look at this graph, okay, and tell us which of these four equations is being demonstrated in the graph. Okay, so what you want to do here is you can see that the linear equation goes through point 2, 4. Okay, x coordinate 2, y coordinate 4. So those would be very good numbers to plug into your equation. Okay, you can also plug in any other point that you see on this line. So here, 3 and 6 is on this linear equation. 1 and 2 is represented in this linear equation, and 0 and 0. So if you were to plug in these numbers into these equations, it would have to balance out. That's what it's asking for you to do. Again, message me if you have questions. Okay? The last one is a hammerhead shark may eat about 4% of its body weight in food each day. If one shark eats about 7.5 pounds of food a day, make a t-table and a graph of y equals 7.5x to show how many pounds of food this shark eats in x amount of days. Use the x values 0, 6, and 8 and label the y-axis by 5s. So again, it's giving you very good details, okay? You're going to plug in these x values into this equation in order to get your y values. Then you'll have your ordered pairs. You'll label your graph by 5, similarly to what you did in the previous question. Plot your points and then graph the equation. Okay? If you have questions, let me know. I will respond as quickly as I can. Good luck, and I will see you all tomorrow.